I think we're a small enough group today. We'll just stick to the one group if that's all right. And we can work on it together. So going back into number one, we're going to look at the relation. Do you think it's a positive relation, a negative relation, or no relation between the two given variables? So first we're given the number of children in the house under the age of 3 and the expenditures on diapers in the house. Do you think those two things would be related? Sure. Do you think there's a positive relationship or a negative relationship? So remember that a positive relationship has, as one goes up, the other's going to go up. A negative relationship means as one goes up, the other's going to go down. So it's this kind of relationship. So as the number of children goes up, would you expect to spend more or less on diapers? More, right? So it's a positive relationship. Interest rates on cars and the number of cars sold monthly. As interest rates on cars increase and you have to spend more per month, would you expect dealers to sell more or fewer cars? Or do you think it doesn't matter? So it's going to be fewer because when interest rates go down, they tend to sell a lot more cars. So when interest rates go up, they tend to send fewer. So that would be a negative relationship. Or a negative correlation. And then the third one is the temperature at noon in a small town and the number of library books checked out that day.
No relation.
No relation. Okay. Okay, part 2. For 100 counties in the United States, the linear correlation coefficient between the infant mortality rate and the average number of TVs per capita was found to be R equals negative 0.84. So we have a fairly strong negative correlation between infant mortality and the number of TVs per capita. So as the infant mortality rate increases, the average number of TVs goes down. So all we know from this is we have a fairly strong linear, positive, forgot the word positive, linear correlation. So you look, how strong is it? Strong, weak, moderate, positive or negative, and then linear correlation. Those are the 3 things that you include. Does this suggest if people own more TVs, then the infant mortality rate will decrease? So if you have a high infant mortality rate in a particular county, should we just buy everybody a TV and that'll solve the problem? No, that doesn't make any sense whatsoever. No. Because correlation and causation are not the same thing. It's not a cause and effect relationship necessarily. So what could be a possible variable that they call a lurking variable, one of my favorite terms in statistics, a lurking variable that may really be what's going on in the situation? Well, what we'll do is we'll look at the 2 things. infant mortality tends to go up in communities that don't have access to health care, that have poverty, that have disease in the community, right? All those things. And why do people have more TVs? Well, if you live in a small apartment, you probably only need one TV. If you live in a big house with 6 bedrooms, you might have 8 TVs, right? So it has to do with the size of housing, which has to do with the income in the area, right? So the lurking variable here that may play a role with both of those things would be money. So infant mortality rates tend to decrease as people have higher income because they have better access to health care. And when people have more money, they tend to have more TVs in their house. So this is probably a little old. Now everybody just has other kinds of screens instead of TVs, but you get the idea. All right. Any questions on that? Okay. So for the second part of the classwork, we're going to actually work with a StackCrunch data file. So I have saved a data file called Apartments in Queens, New York City, Chapter 4 Classwork. So you can find it in your StackCrunch. And I'm going to bring that up. So if I open StackCrunch, I can just go to Data and Load. And from my groups, and you can select the group for this semester. And if you scroll to the bottom, you'll see the one with the house or the apartment, which is where I put for the picture. So the data looks like square footage in the first column. I'm just going to move that over so we can read it. And the rent per month in the second column. So the number of square feet in an apartment and the rent per month. So looking back at the classwork, include a scatter plot using the square footage as the explanatory variable. So we're going to get the square footage and we're going to, you can either paste it into the document or you could just do it as a separate document and save it. So we'll go to stat and regression, simple linear. Just making sure you can see that. Okay. So my X variable is square footage and my Y variable is rent, because we think the number of square feet is going to predict the rent of the apartment. And that's all you have to click are those two and click compute, and it does the rest. I'm just going to pull this over and make it bigger. Oops. So to get the graph, you're going to use this lower arrow, and it brings up the graph of the fitted line. And then to make a copy, go into options. You can either save a copy and then just attach it, or you can click copy and right-click to paste it into a Word document, and then upload the Word document, however you want to do that. Okay. So as you see, it's a fairly strong correlation, I would anticipate, because most of those dots are very close to the line. So I'm going to, no, I don't want that. I'm going to go back. And we're going to look at what we have for our variables. I think the next thing it asks for is the correlation coefficient, I'm guessing. So our correlation coefficient is 0.96861086. So that's a very strong positive linear correlation.
It's showing up a little blurry. I don't know if I'm the only one that can see it like that, but
It's blurry?
yeah.
Yeah, it's blurry a little.
Here, let me try stopping share and I'll share it again. Is that any better? Or is it still blurry?
It's still blurry. It was like, before it was fine.
That's weird.
When you was like adjusting it.
Let me see if I can make it big.
It just looks like a whole bunch of letters and numbers squared together.
Oh, bummer. All right, well, we'll just do the best we can then. I'm going to go back to the homework. Okay, is this better?
No, it's the same.
It's
I don't know,
blurry?
if you like your Zoom thing or something, like the.
So does this look blurry, Keisha?
Yeah.
Okay, we'll just walk through it and I'll just talk you through it. Okay, so it asks to put the scatter plot. It asks for the linear correlation coefficient, so that's the R, which we got was around 0.98. It asks you to compare the linear correlation coefficient to the significance table. And if you go back to the PowerPoint, you'll have a copy of that table. I will put one into your e-learning too. There's also one in the back of your textbook. But I'll throw one up in e-learning so you can have one. Then it says determine the least squares regression line. So you grab that from StackCrunch. I'm going to try, if I stop share, and just stop it for a second and share again, see if it's any better. I just wonder if the internet's wonky here. Does that still look bad?
No, you know how at the yeah, percent is at 120. That's why you gotta bring that to 100 on the top of the where you like type in to go to a
Right
search.
here?
Yeah.
Okay. Is that blurry or is it better?
It's the same.
Is the same. Yeah, I don't think that's what it is. I think it's the internet connection.
Oh.
So it's the rent per month is going to be negative $399.25 plus 2.53 times the square footage.